take a look here, folks, up front. So, you notice here at the top, it says Polynomial Practice Exam. Okay, so we're going to go through this. All right, we're going to go through this here together, refresh our memory on some things, and then see where we're strong and also where we're weak, so we can know what to look at tonight and review tonight too. Okay, so number one, we're asked to identify each from the given polynomial. Okay, so we're given things to identify, okay, about this polynomial right here. So let's go here. For letter A, we're asked to express f of x in standard form. Okay, so Reagan, is this polynomial in standard form? Okay, how do you know? We don't know. Okay, someone help us out. Is it in standard form? Dylan, you say no. How do you know, Dylan?
Because it's not in various numbers.
Okay, what number specifically? We're looking at the exponents, right. So Reagan, you'll see here that we got an exponent of 2, then there's an exponent of 3. So this one, because it's the highest power, should be in front. Okay, so in standard form, it'll be f of x equals negative 5x cubed. Don't forget there's that minus sign in front there. Okay, and then Reagan, what's the next highest power that we have after the cubed? 4. Yep, so plus 4x squared, and then what's the next highest after that? 2x, and then minus 8. Relax, Alex, relax, okay? Calm down. All right, so there is our answer in standard form. Okay, very good. Let's go here to Erica. Erica, how many?
Oh, great, I'm back.
I know. It's okay, it shouldn't be too bad. How many terms are here?
2.
More than that?
What? Terms?
Terms. How many terms are in this polynomial?
3.
I see 1, 2, 3,
4.
4 terms. 4 terms there. Remember, folks, terms are separated by addition or subtraction. Okay, terms are separated by addition or subtraction. Okay, very good. Let's go to Hannah. Hannah, what is the lead coefficient of this polynomial?
So they're not
Negative 5. Question?
they're not divided by multiplication.
Correct. Yeah, we're not factoring here or anything like that. We're not going to take out a GCF or group them or anything like that. Not yet. We haven't been asked to do that. What's that? Yeah, so there's no like terms here either to simplify. It's just you go from a highest power on down to the lowest power there. The lead coefficient then is negative 5, right? Because this is the coefficient of the highest powered term. Okay? If you were looking at this polynomial, the lead coefficient is still going to be negative 5. Even though 4 is in front, the lead coefficient is always the coefficient of the highest powered term. Ben, not here, please. Sorry, I just don't want people to be distracted. Okay? What is the degree? Daniel, what is the degree of this polynomial? Not 5. Nope.
No, it's 3.
It is 3. Very good, Daniel. And the degree just refers to the what?
The highest exponent.
Highest power, highest exponent. Exactly right. Okay? And then we want to evaluate f of negative 3. Okay? To evaluate f of negative 3 here, Kendall, what does that really mean to do? To evaluate this, what does that mean to do? Plug in negative 3. So you guys go ahead, take 30 seconds to 60 seconds, evaluate f of negative 3. Go ahead, do it. Use your calculators if you need to. Please make sure you use parentheses around the negative 3 when you plug it in. Use parentheses around that negative 3 when you plug it in. Otherwise, you're going to get the wrong answer. Okay, 30 more seconds here. 30 more seconds. Finish up letter E. 1E. 1E. Give me the answer for f of negative 3. 1e, f of negative 3. Okay, let's go to. Ooh. Let me see here. I've got. Let's get someone we haven't heard from yet. Carson. Carson, what do you say here? For E. What'd you get? Uh-huh.
Plus 4, then negative 3 in parentheses. The second power
Uh-huh.
2, negative 3.
Uh-huh.
Minus 6.
Uh-huh. And that equals what? No, sorry, what's the value? When you do that arithmetic, when you like multiply it all out, everything together, what do you get? What's the value? Did you type it in your calculator? Oh, that's I'll just say it right here. Okay? 157 is what you should have gotten. So yes, that's right, Carson, but then don't forget to then actually do that and get the answer. So 157 at the end there. Okay? Shh. Question. Shh. Girls. Yes? You have to show work for letter E? Number E?
Yeah.
Letter E, you mean?
No, because like it's something it's moving math.
Stop
not
at the E
English.
means.
Like so you did f equal 3, and if you didn't put all that in, we have to show the work.
Oh, are you saying can I just write 157?
Yeah.
Absolutely, yes. That's fine. Yes. Okay. All right, Roman numeral 2. Let's keep moving here. The directions here now have changed. It says perform the indicated operation. Express all responses in standard form. That means standard form, again, standard form, we take the highest power down to the lowest power, okay, kind of thing. So this was standard form, right? This was not in standard form because the 3 should be in front there. This one now is standard form. So we're going to have to do the operation and then put them in standard form. Yeah, yes? Okay, so Shepard, what is the operation we're supposed to do here? What operation are they indicating here with this work? What are we doing?
I don't know.
Not sure. What's the sign between the parentheses there?
Oh, subtraction.
Subtraction. We're subtracting. Okay. So in order to subtract, in order to subtract polynomials, when we have a minus in front of parentheses, we're going to change it to plus, and then everything in here we're going to do what? We're going to make it the opposite. So we change the minus to a plus, and then everything in here becomes opposite. So negative 3, negative 6, negative 4, positive 4, positive 2, like that. Okay? And now, yeah, you're right, Shepard. Now we're going to add them. Okay? So to add these, well, let's take a look at the 5x to the 4th. Is there anything like with a 5x to the 4th?
The 6x. Or no.
And it's got a cube, so nope.
So, no.
Not in here, but what about over here?
Yeah, the 6x part.
Well, that's sorry, it's supposed to be a negative 3. It's my hand. It's probably you can't see because of the way I put the negative in there. But it's a 5 and a negative 3 there. So that makes 2x to the 4th. Okay, and we took care of that. Is there anything like with the negative 6x cubed? And again, look over here maybe.
The other negative 6.
Yeah, so negative 6 and negative 6 makes negative 12. Okay, how about the 7x squared there? Shepard, what does that go with?
The negative 4.
Very good. So that makes positive 3x squared. And again, you can just do 7 plus negative 4 in your calculator, and that'll give you the positive 3 there. How about the negative 2x, Shepard?
The 4x.
Yeah, so negative 2 plus 4 is positive 2x. So that's gone. And then 5 is like with the 2, right? So we get a 7. Okay. Thank you, Shepard. So Matthew, is this in standard form? Matthew T, sorry, is this in standard form?
Yeah.
Yeah. Highest power, next highest, next highest, next highest, and then the constant. So perfect. Good job. Okay. Go ahead, guys. Try number 2. This one is what operation? What operation is this one indicating? Adding. So now you don't need to add the opposite. You just really just combine like terms now. It's just addition. So go ahead, try number 2.
So you just want us to physically equate and look at the one and not
Add like terms. Yep, add like terms. Yep, all you gotta do is add like terms there. Okay, so go ahead, try number 2. Ella, question? Today, or I was thinking maybe tomorrow to finish the test early, potentially. So it's your choice. What would you prefer to do? So number 2, folks, go ahead, try it. Mark, turn back around. You're working on number 2. Okay, this is not time to socialize. Correct. The X will stay the same. Right, so you go back. All right, yes, Dylan?
This is when my unit become a positive.
So why did the negative become a positive?
No, you multiply everything in there.
Wait, there's all signs like plus everything. No, but let me see how this is like that or this. Plus not all those. Yeah.
No. This one, because we were subtracting, and the subtracting was front and back, so we like distribute the minus sign, make it a plus, and make all of these But this, because we're adding, you like literally just combine like terms. That's all you do. You don't change any signs. Just add them together.
I don't do that. Sorry.
These two is 6 minus 6.
It goes away, disappears, right? Because if it's a positive 6 and then a minus 6, it just disappears. You could put a 0 if you want to, you know. You got it? I don't know. I can check and see. Looks pretty good, though. Looks pretty good. Okay, good job, guys. Very, very good.
This is what I finished the checking.
We're going to go over here in just a second.
Wow.
I never really got into one I went to your sponsor. Maddie. Only because they're hot. One thing you said?
Do you want to work on these while we're reviewing?
I like them because I saw them. They're literally like hot. Yes, they are.
Both of these, and there's one actually.
The blue one.
Another question?
Okay.
No, not.
Time's up, folks. Time's up. Let's take a look here. So,
I'm just saying like they're really like dull.
number 2. Here we go. So, Alex, 3x to the 4th. That is like with the what? 5x to the 4th. So we get 8x to the 4th there. That's gone. Okay. Alex, 6x cubed is like with the...
6x cubed, but negative.
Yeah, so they're going to cancel, and we don't have to write anything. If you want to put a plus 0x cubed, you can, but it's not
No,
necessary.
don't do that.
Don't do that. Okay, how about 4x squared there, Alex? Is
7x
like...
squared,
So
you
that
get
makes...
11x squared.
Okay, good.
And then you get negative 4x to negative 2x, which is negative 6x.
Good. Yes. And
negative 2, 5, negative 3.
positive 3.
Oh yeah, positive 3. I didn't
And
write
there it
positive
is.
3,
Oh,
but
you did. Okay, you just misspoke.
I wrote them. I said them in different orders.
Oh, okay. That's fine. So now, is this in standard form, Alex? Is it in standard form?
I think so. It's like
Highest
no,
power?
Standard, I think it is because
And then that's the next highest, and then that's the next highest. And so, yes, that is standard form, right?
would the negative have to go at the end since it's negative?
So it's the powers that determine the order. So it's 4, then 2, then 1, then no power, right? And so this is in the correct order.
Okay. Thank you.
All right. Turn the page. Turn the page here. Okay. Matt T, how do we multiply something like this? What are we supposed to do? Distribute, right. So 3x squared times 4x, 3x squared times minus 3. Okay? Matt, what will it be? We do 3x squared times 4x. What's that going to give us? 12x to the 3rd. Good. And then 3x squared. Okay, very good. Right there, folks. Okay, we're multiplying. It's gone. Okay? That's it. That's all you had to do. We just multiply there. That was the indicated operation. Okay? Let's look at number 4. Number 4, okay, Mark, what's the operation we're supposed to do here?
I did add or no multiply.
Yeah, multiply because they're next to each other. Multiply. That's right. Okay? Mark again. we have 2x plus 5, that's in front of the parentheses here. So just like the 3x squared was in front of the parentheses and we distributed it, we're going to take that 2x plus 5 mark and multiply it with a 4x. So we get 4x times 2x plus 5. And then the 2x plus 5 will also multiply to the minus 1. So it'll be minus 1 times 2x plus 5. Okay? What do we now have to do, Mark? At this point, we still have to do one more thing. What's that? Distribute again. So 4x times the 2x. 4x, we'll get to that. 4x times the 5. So yeah, 4x times 2x is 8x squared, though, because it's 4 times 2, 8, x times x squared, right? Mark, 4x times 5, what's that going to give us?
20x.
Very good. Okay, why is it minus, you said, Dylan? Because it's a negative 1 there. It's a negative 1. So when I do 2x plus 5 times that negative 1, it'll be negative 1 times the 2x plus 5. Okay? We distribute the 2x plus 5 to the negative 1 there. So it gets that. Does that answer your question? Okay. So then the minus 1 also distributes, right? So negative 1 times 2x, minus 2x. Negative 1 times 5, minus 5. Okay. Is there any more work that we can do here? Let's say, Sean. Sean, is there anything more we can do here? There's no more multiplication, but what else can we still do here?
We have to combine like terms.
Yes, good job, Sean. That's right. What are the like terms in this case?
20x and negative 2x.
Yes, so we get 8x squared. 20 minus 2 is 18x, and we still have the minus 5 there. Okay, Sean, is this in standard form?
Yes.
Yes, it is. We have the highest power, then the next highest, and then, well, no power. So that's our final answer there. Okay? That's all there is to it. Questions on number 4? All right, let's skip then to number 5.
I just finished writing that.
Oh, I can zoom out a little bit there. Okay, number 5. 3x plus 2 quantity squared. Okay, Matt S., when you square something, what does that mean you really do?
Just double it.
Not double it, you multiply it by the same thing. There we go, that's right. So you double it because you write it twice. Maybe that's what you meant there. Yeah. So 3x plus 2 squared, bless you, is 3x plus 2 times 3x plus 2. Okay, and then we're going to multiply it. It's just like number 4. So go ahead, try number 5. Okay, it's just like number 4 we did there. Try number 5 now. So go ahead, take a minute or two, and multiply together number 5. Okay, go ahead, try it number 5. Okay, so again, try number 5, please. Make sure you get your final answer in standard form. Okay, so try number 5, please. Try number 5. Distribute if you need to there.
The answer's on the. I didn't ask for it before.
So unfortunately, no. You're close though. But so you don't just square this and you don't and square this because can I write it red? Is that okay?
Yeah.
So yes, you're going to take this and multiply with 3x and multiply with the 2. So you're going to have 3x times 3x plus 2 times 3x. So 3x plus 2 plus 2 times 3x plus 2 as well. And you just do it one more time. So 3x times 3x, there is your 9x squared. So you're right about that. But then 3x also multiplies with 2, so you get a 6x. And then the 2 times the 3x gives you another 6x. And then the 2 times 2, there's your 4. So you're partially right. There's your 9x squared, there's your 4. But you also have these middle terms that show up too. That you can combine. Okay, does that make sense to you there? It's just like we did number 4. It's just like number 4. Okay, again, try number 5. Try number 5. Multiply it out there. Need help with number 5?
When we start
that, but they're like, right? They both have an x. So what's 6 plus another 6?
So I just do that thing here.
Cass, you okay? Questions? So, yes, 3 times 3x times 3x and 3x times 2. And then you do 2 times 3x times 2 times 2. Yes. So basically, Matt, the idea is everything in here multiplied with everything in here. So it's helpful
I
that
honestly not trying
3x
to
times that, 3x times that, 2 times that, 2 times that. And then add like terms. So you have it.
every
Okay,
2
question.
years.
30 more seconds, folks. We're going to go over this.
But I don't think I can like like that. Like he was a cop.
So, hang on a second.
I got a fun one.
Had like
So,
what are we doing? I think today he's more.
We're on the right track.
He gets more stuff done today than
They both need to be negative. But
he only.
think of other numbers multiplied by 24. Okay, let's take a look here. So we should have gotten number 5 to be this. When you combine your like terms, 9x squared plus 12x plus 4.
Oh, I got that.
Good job. Air high five. All right, so number 5.
I did not get that.
Knock it out.
I tried to like. Oh, God. Yeah.
So, what are we supposed to do here then, Alex, right? What are we supposed to do? 3x plus 2 times 3x plus 2. Again, this is in front of parentheses, so distribute it. 3x plus 2 times 3x. So you get that, right? 3x plus 2 times 2. So just get that. Then distribute one more time, and then get this. Like terms, combine make 12, and there's your final answer. Okay, that's what you got to do. 6 is the same way. 6 is the same way, okay? So we have 3x minus 1 in front of the parentheses here. So we're going to distribute this 3x minus 1 to what? So 3x minus 1 multiplies with the, go ahead, Reagan. X squared. What else? And, yeah, the minus 5. That's it, okay? So you're going to have to write out here x squared times 3x minus 1 plus 3x times 3x minus 1. Whoopsies. Okay, minus 5 times 3x minus 1. Okay, so again, I did the 3x minus 1 times x squared, the 3x minus 1 times the 3x, the 3x minus 1 times minus 5. 1, 2, 3 there. Okay, 3 products. Okay, and then once we've distributed this, what do we still have to do now? What's our next step here, folks? Distribute again. X squared times that, x squared times that, 3x times that, 3x times that, negative 5 times that, negative 5 times that. Okay, so there it is, all distributed out. There it is, all distributed. Okay, are we done? Once I've distributed it out like this, what do we still have to do? Simplify by combining like terms. That's right. So 3x cubed, no other cube terms, so it's just 3x cubed. Okay, minus x squared, 9x squared, that makes then 8. So plus 8x squared. Minus 3x minus 15x minus 18x, and then plus 5. Okay, is it in standard form? Yepers. Okay, so there's an answer. What time does this class end? Schedule's on the backboard. Oy vey. Okay. Wait for this next one and I'll let you go. Number 8. Number 8. Shh. Moving on here, folks. Turn the page. Turn the page. Write the polynomial expression representing the area of the larger rectangle. How do you find the area of a rectangle? Multiply the size. Length times width. I want you guys to go ahead. Do number or letter A here for number 8. 8A, write a polynomial expression representing the area of the larger rectangle. So go ahead and do it. Write the expression for the area of this larger rectangle here. Write it out. Okay, you have a question? I'll right there. 1 sec. Let me just finish writing this out. Okay, so go ahead. Letter A.
What's your shoe size? 9? What small feet?
What is your socks?
They're socks. What's one?
Okay, I'm coming.
No. Daddy thought my shoes are cheap.
0.
Look, my toes are so cute.
Oh, no, it should just be 0.
Anybody know how to do this?
You can, so this is not wrong, but it's not going to be helpful either because your minimum term is always just x. What plus 0 x. You're welcome. I'll go. You're writing the column expression.
These are also wider.
Larger rectangle.
What? These are also really
Good job. You can multiply it out there too. Okay. Yes, I think one of them doesn't work. Here. Yes. Okay, letter A. Here's the answer. There it is. Okay, that's the area of the larger rectangle. Did you write this out at least? Did you multiply these two together?
Wait, why is 3x, why is it 3x minus 2?
Oh, you're right, Mr. Wid. Got him. I made a mistake, so hang on. 3x plus 2. Thank you, Sean, for pointing that out. So let's see here. It should be plus 4x and then minus 6. So we get 6x squared minus 5x minus 6. Is that better? Yes? Should be this. So my mistake there. Okay? For some reason I put 3x minus 2. 3x plus 2 times 2x minus 3. So, yes, Reagan, yes, no?
Yeah, I just didn't.
I don't know.
Did you have the setup correct?
I did that setup, yeah.
Okay.
Yeah, so yeah.
That's half the battle right there. So you did set up right, and then you just got to make sure you multiply it correctly. So 3x plus 2 comes to 2x. 3x plus 2 comes to minus 3. And then it should be like
So wait, do you get out later?
Shh. We get out at 12:40.
That's Saturday.
That's not really
Same time we got out yesterday.
No, but like.
No, it's
Oh,
2
like-
hours.
It's earlier, but we started earlier too. It's early because we started. Normally this class starts, like 11:35. I want to say. So anyway, 11:30. Anyway, shh. Next, Alex, Mark, Dylan. Okay, you're right. You're very, very minutely involved. Write the polynomial expression representing the total area of the entire figure. So what does that mean we have to do? We already have the area of this, and if we want to find the area of the whole thing, what do we still have to do? Find the area of this and then add them. Right. Okay? So we're going to take the big rectangle, 6x squared minus 5x minus 6, add to it the area of the smaller rectangle. Okay? And so to find that area, let's go to Kendall. Okay, Kendall, to find the area of this smaller rectangle, what are we going to multiply there? X plus 2 and x plus 3. You got it. Yeah, go ahead. Okay. And then Mark, you can go now too if you need to go. Okay, so here's the expression, but we've got to simplify it, right? So there's the area of the big rectangle that we got from the previous problem, and then there's the area of the small rectangle that we have to multiply it out. So x plus 2 times x, and then times the 3. So x times x plus 2, and then 3 times x plus 2. Okay, and then distribute, 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 distribute. So x times x is x squared, x times 2 is 2x, 3 times x is 3x, 3 times 2 is 6. And then finally we need to do what?
Simplify.
Yeah, combine like terms. So 6x squared and x squared is 7x squared. Negative 5x plus 2x plus 3x, those are going to exactly cancel. And then negative 6 plus 6, that also exactly cancels. So we're left with just 7x squared there for our area. Pretty interesting. Okay, then Alex, letter C here, Alex. We are told that x is 5 feet, and we're supposed to find the area of the figure. So, Alex, what should we do now? If we know x is 5, what should we do with that 5?
We should move it into the problem.
Okay,
somewhere.
yeah, and so plug it in here, right? That's the area of the entire figure, so put
just
5 in for
7
x.
times 5 to the second power.
Yeah, 7 times 5 to the second power. Okay. Just plug 5 in for the x right there to get the total area then, to get the actual area of the figure. If x is 5, plug 5 in for the x right there.
Where did we get 7x though?
7x squared plus x squared makes the 7x squared. So 5 squared is 25 times 7 is going to be 150. Wait a minute, no, 175. My bad. Okay, 175 feet squared. I guess I should include units too. He's practicing his balance, I guess. Okay, turn the page. When Mark comes back. Okay, folks, we're getting there. We're getting there. We're making it. Number 10. Katie owns 2 different restaurants, Algebrinos and McMath, and has asked both restaurants to determine the profit from different months in the previous year. The manager of the 2 restaurants report their profit expressions in terms of X months, as shown below. There's Algebrini's profit expression, and there's McMath's profit expression, where X is the number of months. Okay? Write a polynomial expression representing the total profit from Katie's 2 restaurants. So if we want to find the total, that means we should do what, Tyler L? Total means what, Tyler L? Add them up. So it's going to be this plus this. Study. Okay, to study, to review this, maybe rewatch the video in places where you need to, get questions answered or, clarified. Okay? And since we're adding together things here, right, Tyler, since we're adding things together, what should we probably do? Combine like terms, yeah. So 7 and 5 make 12. 4 and 11 make 15x. And then negative 20 and positive 10 make a minus 10. And so that is probably what we want to get there. We want to combine like terms. Okay. Letter B says, write a polynomial expression representing the difference. Difference means what operation? Subtraction. That's right. So we'll do 7x squared. Now, it doesn't say which 2 to subtract. It doesn't say that we have to do Algebrini's minus McMath's. Oh, that says Brini. That says Brino. Typo. So I'm going to guess that we should do Algebrini minus McMath. Go ahead. I like Algebrini too. When he comes back, yes. Okay, so take Algebrini, subtract McMath. We have a minus in front of the parentheses, so that means that minus sign is going to... When you have a minus in front of parentheses, what does that mean? We're going to distribute. Yeah, so make it plus, and then make all these opposites. Okay, so 7x squared plus a negative 5x squared, 2x squared. 4x, negative 11x, negative 7x. minus 20, and negative 10, negative 30. There's the difference. There's the difference. If the test tomorrow doesn't specify, I will accept either subtraction. So I will also be okay if you did McMath minus Algebrini's tomorrow. Okay? Either one. Okay. Letter C. Which restaurant had the greater profit after 6 months? What should we do with this? How can we figure out which restaurant had the greater profit after 6 months? How should we figure that out? Tyler C., what do you think?
Okay.
Here's Algebrini's profit after X months. Here's McMath's profit after X months. How can we figure out which one had the greater profit after 6 months? What should we do?
Okay, let's assess. So we have those two, right? We can
Sacred right.
subtract them. We can subtract them, and then one has the greater number at the end. So
I see what you're saying. That could work. Yeah, okay, that could work. That could work there. I think you're going to do extra work if you do it that way, though. This describes the profit of Algebrini's for X months. So just put 6 in, see what the profit is after 6 months for Algebrini's. So we'll do 7 times 6 squared plus 4 times 6 minus 20. And then we'll put the 6 in here. 5 times 6 squared plus 11 times 6 plus 10. Okay, and see what the profit is here. Okay, so let's see here. I get $256 here. And then here, I get $256 here. So, which restaurant had the greater profit? They're the same. So, which restaurant had the greater profit? Neither. They're the same.
Neither. I like how you did that.
What a beautiful show.
Thank you. This is. Are you not entertained? Okay. Letter D. After how many months will the profits be the same? Well, we just figured that out, didn't we? I think there was an error here, and thank you, Alan. I think there was an error because probably we weren't supposed to get the same answer here. So either way, so yeah, 6 months. Hypothetically, though, what if we wanted to try, and figure out after how many months the profits will be the same? What should we do with these two profit equations to see when they'll be the same? Set them equal to each other and then solve. So 7x squared plus 4x minus 20 equals 5x squared plus 11x plus 10. Okay, to solve this equation, we need to make sure that it's equal to what? Since we have x squared and x's in here, in order to solve these kind of equations, we have to make sure it's equal to what number? 0, right? It's got to be equal to 0 for the zero product property here. So we have to subtract everything over. So minus 11x minus 5x squared minus 10 minus 5x squared minus 11x minus 10. Sorry?
Is that minus 20 or?
It's supposed to be a minus 20 there, yeah. Okay, that are gone, so we're equal to 0. We get 2x squared. We get minus 7x. We get minus 30. Okay. Is there a GCF to factor out here? No. Nope. Okay. So, Ben, do you remember how to factor this stuff then? There's no GCF, so we're going to do 2 times the... What? Nope, not times the what. I did. 2, to factor this, 2 times the...
2 times the 7.
Nope. We're going to multiply by the negative 30 there, so we get negative 60. And remember, Ben, we're looking for 2 numbers that multiply to negative 60 but add to negative 7. 2 numbers that multiply to negative 60 but add to negative 7.
Okay, do I have to think of them?
Yeah, I'm going to try and help you here because it's probably... Ooh.
I would just skip the question.
Yeah.
Skip the question. Well,
Well, let's do it.
Is that what bound was?
Oh, I got it.
would have to be
Negative 12 and positive 5. Negative 12 plus 5 is negative 7, and then times that is negative 60. So we get 2x squared. Shh. So break up that middle term, negative 7x, using the negative 12 and the 5. And then, Ben, now we have it broken up. What should we do from here now? Do you remember?
Well, I think you have to add the like terms.
No, that'll bring us right back to here. That's not what we want to do. I mean, it's not, I mean, yes, that's a thing we could do, but we're trying to factor. Remember, we want to group the first two, Ben.
Okay.
Group the second two.
Second two.
Yep. And then, Ben, what can we take out of these two terms? It's in common here.
2
A 2 and
x
an x. So we'll take out a 2x, and we're left with an x minus 6 here. And then what can we take out from here, Ben?
5
Yeah, so plus 5. Take a 5, dividing 5x by 5, what's going to be left here?
divided by 1
Oh, a 1
x
x, or just x. And then what's negative 30 divided by 5?
6
Yeah, negative 6. And look, we have a negative 6 there, so it's x minus 6 times 2x plus 5 equals 0. And so we'll set. Again, we have a zero product property here. X minus 6 mark equals 0. 2x plus 5 equals 0, so x equals 6. And then 2x plus 5, subtract 5 from both sides.
0
0 minus 5 is negative 5, and then divide both sides by 2. So I'm out of space. X equals negative 5 over 2. Okay? Now, you'll notice here we only answered with 6. Why don't we include the negative 5 halves as an answer? Go ahead, Tyler. Why doesn't it work? Well, actually, no. This negative 5 halves is a solution here, but what about the context, Tyler?
In the context doesn't work
Why not?
because you cannot have that time.
Yeah, that negative number of months, right?
Yeah.
Okay, we're not going to go like back in time or something like that. We're 6 months. That's what it is. Okay, yeah, exactly right. We don't have a DeLorean or a flux capacitor. Okay,
Hey, that was my favorite movie.
or a TARDIS. Back in the day,
Back in the day.
I was about to say, back in the future.
I believe you. I've never seen it, but I want to. Okay, here's what I want you guys to do. Shh. So now I'm going to have you guys try numbers 1, 2, and 3. 1, 2, 3 here. Give those a try, please. 1, 2, and 3. The directions are now to factor. So factor 1, 2, and 3, please. 1, 2, and 3. Okay? Factor 1, 2, and 3. Shh. So try 1, 2, and 3, please, on the next page. Try 1, 2, and 3. Factor them.
Oh, I got this.
This is the expression here. But if you're told then that x is 5, you can actually multiply it in 5, 7, 25.
Like, once you say mom,
No.
Alex, do this with your hair, like do like this. What, do you have dander? What? Do you have dander? Like the white stuff in my hair?
Alex and Mark, 1, 2, 3. Let's go, guys. Right there. Factor, okay?
It's not danger, I know what it is. Oh, then it's not danger. It's not lice. Dylan, you're the only one that. Wait, Dylan has lice? I'm gonna keep my hood on. Yep, I was. Stay away. Dylan, what music do you listen to? Dylan. This is the garbage. This is the country and pop. I listen to rock, K-pop. What?
Guys, excuse me. Too noisy. I know you're not done. 1, 2, and 3. Let's get done. Come on. Mark and Alex. Shh. Erica, Liv. Shh. Let's go. 1, 2, and 3, please. Okay. Erica, let's go. 1, 2, 3, please. Get started. Let's slide out. Factor. We're first now. Be careful. So, oh, I see what you're doing. I see what you're trying to do. It's not teaching you. Okay, I see what you're trying to do. Come on, that's not possible. And this is for this one right here. This is the difference of squares. Wait, what? Okay. Guys, let's get factored here. 1, 2, 3.
Sorry.
1, 2, 3. Good job on the first one, Rick.
I downloaded it once, but like
GCF that one, okay? So what you come up with, Alex, GCF here, okay? Cool stuff, but make sure you're also trying number 1, GCF, okay? There's a GCF here. Try to find the GCF number 1. Yeah, no setting equals 0. It's not an equation. We're just factoring. That's what we're doing right now. On the back of this paper will be setting GCF. Factor.
The greatest common factor between 6 and 18.
Yes. And then also the x's too.
it's 6. Okay, we'll tell you about it.
Yes, it's 6.
I just write 6.
So 6, and then there's also x you can pull out too. Your fact.
Yeah,
Yeah. So 6. And then let's put parentheses. We take 6 out of this. What's left?
5, because I'm writing like that.
Yeah, you can do it that way. Oh, what careful. 18 divided by 6 is 5.
So why do you watch this?
So minus 3.
You're so trash.
Double tap.
More! Anything else in the top?
Okay.
There you go.
I just know how it's going to write.
Okay, I got you. Yes. Actually, I had the original Warcraft. Yes. Early.
Remember Clayton's last name?
I played Warcraft, the original Warcraft.
Wait, so
DOS.
I should do like that?
You know, I was probably in elementary school when that
Wait,
happened.
hold on.
He's a red
What was his last name?
I don't know.
Clayton. He sounds like a used to get dark squad.
Wait, but let me stop.
Oh,
Which
yeah.
campaign is it though?
He's
That's-
so, he's awful. He's
I think last year they speedran the undead campaign.
literally,
So now
he
there's
asked, he tried
because there's
asking
three different
me to-
classes you can play as. What's that?
Do they do Mario?
I didn't ask
Oh, yeah.
him.
This is so easy to speak on.
I know, I don't.
But they like doing like 10 minutes.
He wanted to fight me.
He's the
Yeah.
most gross.
They beat like you saw them in the Skyrim one. They beat it in like 5 minutes.
Yeah, they beat it in 2 minutes. Shout out some serious cheats right there.
So that was
It's
this
like
video.
glitches. It's glitches.
No, they jump through
Yeah.
walls and fight you.
Yeah. Because the game's really bugging, so that helps
So
them.
once I get this, what do I do? I thought
You are finished at that point. You're done. So then number 2, you can see you have 4 terms. So actually in this case, it's already grouped. So just group and insert back because you already have your 4 terms. It's this one we have to do the 1 times 1 14. Because it's trinomial.
Mr. Wood, I got number 1, I think.
Okay, right there. 1 second.
I got one number. Good job. That was really good.
No, you are finished.
What is
This side.
Wait, you want to check answers? I got 3 responses. Dylan, I thought
calm
we
down?
were Dylan got 3 responses. I got 3.
Finish your question.
Dylan, you're wrong.
Okay, very good.
You just have to use the factors. They look at x factor 4x. No, but you're on the right track.
Dylan, you won.
Oh, this is way better than this is Forge, like,
No!
Okay. Give you like 1 or 2 more minutes here. 1 or 2 more minutes. Let's stop taking each other's electronics, please. That's sad.
I think the only thing that survived was the 16-year-old power supply. The rest of them just fights.
That's something.
I'm kind of scared putting the power supply in because I don't
Right, you want to like fry something else.
well, I don't know if fry my computer.
Right.
All I know is everything's dead.
Yes, better to start from scratch. Okay. 1 more minute. 1 more minute.
I'm still on number 1.
GCF, Mark. GCF. What numbers can you take out from both? And then how many x's can you take out from both?
This is all
saw the two.
You should teach them.
Okay, so you put 6x to the fifth power
That is not how you
x
teach.
to the fourth power. You understand? Oh yeah. And then you do 6x to the fourth power. Parentheses 6 minus 3.
Really great at this.
And that's how you get the answer because you know you have
He doesn't know number 2.
All right, folks, let's turn back around, please. Take a look here. All right. Shh. We're going to go through 1, 2, 3. All right. Thank you. Number 1, go ahead, Dylan.
Okay. 6 parentheses x to the fifth power minus 3x to the fourth power.
Okay.
Parentheses.
Great.
And you get 6x to the fourth power parentheses x minus 3.
Okay, right. So remember, folks, that you can take it a piece at a time. You don't have to take the GCF out all at once. So, for example, Dylan he just focused on the numbers first, and he saw, okay, I can take a 6 out of both of these, leaving behind a 1 and a 3. Then he looked at his x's, and it's like, okay, the most we can take out here is x to the 4th, so I'm left with an x, and then, well, that'll be all gone, so just 3 there, and that's our final answer, and that's right. Okay? Number two, to factor this, I got it, I'll get it. To factor that, we will group them. They're already 4 terms, so group the first 2, group the second 2. Okay? What can we take out from that first group? A 3 and an x to the second. So 3x to the second, and we'll leave behind an x and a minus 2. And what can we take out from the second group? A 5. And we leave behind an x and a minus 2. So they both have an x minus 2. And then we'll be left with 3x squared plus 5. Okay? Now some people were asking me, Mr. Whitmire, should I set these equal to 0 and solve them?
No.
The answer is no. There is no equation here, right? We're just factoring. That's all the directions say. Okay?
So how do you know what
Oh, okay. Fine. Number 3 then. Good. That you figured it out. Number 3, it's a trinomial. Okay? Is there a GCF we can factor out here? Nope. Okay, so we'll just do 1 times the negative 14. So we get negative 14, and we're looking for 2 numbers that multiply to negative 14 but add to negative 5. That's going to be negative 7 and positive 2. So we break up that middle term. Okay, group the first 2, group the second 2. Okay, from the first group we can pull out an x. The second 2 we can pull out a 2. And they both have an x minus 7 in common, so it's x minus 7 times x plus 2. And there's that factored. Okay. Now we're running short on time here, so I just want to briefly discuss some of these other ones here. Okay. 14, that's one of those difference of squares problems where you're going to want to put in a 0x here. Okay, and then factor from there. Okay. 5 and 6, take your lead coefficient, multiply it to the back, and again, just look for 2 numbers. So this one will be 6 times negative 3, negative 18. Look for 2 numbers that multiply to negative 18 but add to negative 7. And then 2 times 20 is 40. Look for 2 numbers that multiply to 40 but add to 13. Okay? Turn over to the back, last page there. Okay? Then on the back, these are your equations. Okay? Nope, no homework, but I'll finish explaining these here, but we're not going to have enough time to do it. So set your 2 factors equal to 0 and solve. Here you need to factor. Then set each factor equal to 0 and solve. Here, what's the problem?
You have an 8 on
Yeah, we need to move that 8x over. So subtract 8x from both sides, make it equal to 0, then factor, then solve. Right? Set each factor equal to 0. And then same thing here. Factor, set each factor equal to 0, and solve. Right? So set, just like here, right? You set each one of these equal to 0 and solve them. Factor each one of these, make sure they're equal to 0, and then solve it. Okay? I've run out of time here, so we'll just stop right there. I'm going to give you this second review, okay? Second review, so it's more practice. I will write up an answer key for this and post it to Google Classroom, so you can check your work if you want to. All right, I'll also post this video here to the Google Classroom as well. All right, so this is one more study for you here, one more way to study for you.
Wait, is there
There is no homework except 2 studies. That's it.
And that was Ocean County. What the one?
I see. That's a delicious drink.
A graphics card.
But it's not a grade worthy of making decisions like that.
There's probably